Namaskar, myself Dr. MP Mishra, Faculty School of Computer and Information Sciences. I welcome you in this session. I am with you in this session on a topic related to object-oriented analysis and design. And in this session, I will be discussing about the basic elements of structural design in UML. And we will see that what are the different type of diagrams which are used in structural design and what are the basic elements which are helpful in understanding the static structure of the system. So let us proceed. And if we talk about the UML diagrams, basically UML diagrams are used for diagrammatic representation of analysis and design of the system, and it is basically based on the object-oriented paradigm. It means that the focus on the analysis and design is towards the real world system in terms of the different existing objects, whether they are virtual objects or physical objects, and how they are interacting with each other, and how in combination those different objects with their different kind of relationship, associations, or different kind of interfaces, they are participating in the system and they are contributing towards the final objective of the system for which we are going to develop the system. So in this context, if we talk about the UML diagram, so there are basically two type of or two categories of diagram. One is the structural diagram, another is behavioral diagram. So the structural diagram is related to basic structure or static view of the system, and the behavioral diagrams are related to dynamic nature or dynamic activities happening in the system. So in this session we will be discussing about the structural diagram, and if we see the basic type of diagram which are provided by the UML or which are available in the UML. So these are the two categories: structural diagram or structure diagram, then behavior diagram. And in structure diagram, the static things or static nature of the system is captured, and these diagrams include different diagrams like class diagram, object diagram, component diagram, deployment diagram, profile diagram. And similarly in behavior diagram also there are several diagrams which are used for representing the different aspect of the system. So as you can see, this diagram is taken from the UML website itself. So these are the diagrams which are the basic UML diagrams for representing structural as well as behavioral aspect of the system. So as we are discussing about the structural diagram, so let us see the main or the diagrams which are used for the purpose of structure representation or structural representation. So in this, the very important diagram which comes in this category or in this type is the class diagram. And then next one is the object diagram. I am saying these two are very important because these two diagrams are the core component of any object-oriented system. So whenever we say object-oriented system, we start thinking in terms of objects, we start thinking in terms of the properties of those objects which are going to participate in the system, as well as we try to see the interrelationship between those objects. And for representation of those conceptual understanding or conceptual design of the system, we use two basic diagrams, that is class diagram and object diagram. Then comes the component diagram. So when we say component, as its name itself depict or is reflecting, component means part which are having its own independent objective, and different parts combined together is making a system. So if we are having different parts and which are in itself properly defined for different objective, and we are combining those different parts to make the system, then we represent through a diagram that is known as component diagram. Then profile diagram, and then composite structure diagram, deployment diagram, and package diagram. So in these diagram, one diagram which is important for us to understand about the system is the deployment diagram. So for that also I will be discussing in little detail that what are the things we keep in deployment diagram and how we try to find out different components in the deployment diagram. Now, if we try to find out the basic concept behind these diagram and try to describe that how the static structure of the system will be represented with the help of the diagram, then we use this structural diagram, and these basic structure basically cover the physical as well as logical aspect of the system. These diagrams basically combine different elements to make the system and show that how they are related with each other and how they are participating in the system. And as I mentioned, some of these diagrams are object diagram, class diagram, package diagram, or modules. Then we talk about the physical aspect also. As I discussed that there is a diagram related to deployment. So physical component or physical node of the system are part of that particular diagram. So physical node components, and then interfaces, and then if we are having some kind of relationship or some kind of implementation, then certain constraints. So these all are the basic component which make the structural diagram feasible or possible to come into actual existence. So if we go a little more deeper and try to understand that what actually structural modeling depict, then we can say that structural modeling is the process of creating coherent representation by aligning and integrating different component models, including physical and virtual objects. As I mentioned, that whether we are taking physical part of the system, whether hardware related things or some virtual related or hard software related things, then different kind of activities, relationship, attributes that help to design the system of that particular static structure of the system. If we are trying to study these aspects in computer science, then we say that we are trying to do the structural modeling of the system. So if the structural model of the system is presented with the help of these diagrams, then the person who is going to implement it will be in position to comprehend those things and to try to find out that how logically those things are related with each other and how those things can be further implemented. Now, once again, if we see on the slide, so here some example of the structural diagram is mentioned: class diagram, object diagram, design diagram, deployment diagram, package diagram, profile diagram. All these different elements you will find in your course material MCS 219 also. So if you see, these things are used for the purpose of static representation of the system. So we can say that structure diagram are not utilizing time related concept and do not show the behavioral aspect of the classifier. Those classifier means the class, object or component in the system which are exhibited in the structural diagram. Now, if we try to find out little more or to understand little more about the class diagram, then as we know, as we have learned some programming language related to object oriented programming so far, so in that also we have seen this definition. Class is nothing but a blueprint of the object. It means that how the object will be actually visualized or will be coming into existence. For defining those things, we define the class, or we create the class, or we conceptualize the class. So class generally represent the group of objects which are related similar to each other. It means their attributes, their functionality as well as their relationship with different object is same. In UML diagram, class diagram is seen as a static structure, and it describes the structure of a system at the level of classifier level, whether it is your class are interfaces. If we talk about interfaces, so if you have done Java programming, in that also the concept of interface come, and that interface concept means that if you are having certain interface and you are defining it, so you are just defining that, and it is the duty of the class in which that interface is being implemented to implement the method which are defined in the interface. So a class diagram basically provide the blueprint. In that blueprint you are having the name of the class as well as attributes and the operation. These operations are in terms of object oriented programming language is also known as methods. Then interface is collection of name operations that describe behavior of the element, but it is not going to implement that behavior. So it is the responsibility of those identifier or those component which are implementing these interfaces to implement these interfaces operation, and it is compulsory for them to implement it. Now component, it basically help us to see the whole system in logical parts, and those logical parts we can say is having some kind of modular existence in the system, and they are having clear objective defined. It means if I am defining a component in my system, that particular component in itself will be having a clear-cut defined objectives, clear-cut defined functionalities. Like on the screen you can see one component is shown as student. So if we take one system which is being developed for the purpose of educational operation, then student, teacher, examination or some other administration related component in the system can be visualized as per the requirement of that specific system or design, and those different components can be created, and by combining those components together the actual system will come into existence. So these components basically depict the structural relationship between the software system elements, and it helps us to understand the functionality of the system or the functional requirement of the system. Then comes another element in the structural design is node. Node is a runtime physical object that denote a computational resource, like personal computer may be the node for a particular system. A server, software server may be node for a particular implementation. There may be more than one server if you are having very large or complex software developed which need to be deployed. Then for the purpose of networking, if you are having some networking hardware like routers or bridges, so those things can form the component of the system. And some other component also may be your normal printer if you are having an environment in which you are having some printer, network printer. You may have some sensor if you are having some application in which some sensing devices are there and you are going to have some data collection. So these are the example of different nodes. Now next comes the constraints. So constraint basically provide us facility to have certain condition. In the design or in the representation of the model. So a constraint refine a model element by expressing a condition or a restriction. Restriction means some kind of operational condition. If we are putting, like if we are taking, let us say the example of educational system. So in that, if a student is trying to register in a program and age is below 15, then university will not permit the admission. So that is the constraint that we are implementing. Another example may be that if you are operating in certain bank and you are trying to do certain kind of transaction and open an account, let us say, so there is a constraint that certain minimum amount or minimum balance must be there in the account So these kind of conditions, if you are putting in your design, then you represent those things with the help of constraints, and these constraints must be in conformity when they are going to be implemented or when the system is in running state. And if the constraint is not being met, so either you will get certain kind of exception or your system will not proceed further and it will stop at that particular stage. Now, related to class diagram, one more diagram is there, that is object diagram. So when we are saying class diagram, it means there are different classes. These classes are associated with each other with certain kind of relations. And if you are in position to visualize a class diagram, in that there are several classes and those classes are related to each other, are associated with each other. And if you take let us say, I am saying you take just picture of your class diagram for a particular moment and you try to create object. And when you are creating object, it means you are putting certain value to different attributes of those objects. So one snapshot of the class diagram is seen as a object diagram. So object diagram is nothing but one instance of a class diagram. One instance means at a particular moment, whatsoever different object available in that particular system are having their state. State means certain values and certain operation. After that, whatsoever attribute values they are having, that define the state of the object. So at a particular moment, if I get the snapshot or screenshot of whole working of those individual objects, so I can go into deep into that particular values, and I can, or I as an individual implementer can visualize that how actually those objects are participating in different kind of operation. So some kind of dynamism of the system also can be visualized with the help of object diagram. Though it is a static diagram, but it helps you to look into the system working and try to visualize some kind of dynamism or functionality of the system. Next diagram is the profile diagram. It basically shows the basic profile and work of the object. It is a kind of auxiliary diagram which allows defining custom stereotypes, tag values and constraints. So if you are having profile of certain thing, then you very easily can depict and understand about that particular thing. So that is the whole purpose of profile diagram, to provide the basic profiling and working of the individual objects or individual component in the system. Then next comes the package diagram. Basically, as a programmer, you might have seen that you are sometime including certain libraries, you are sometime importing certain libraries depending on the certain programming language, or you are using certain library, or you are using certain function already defined. So there are something which is already predefined that we use for the development of the system. But similarly, if in my system I am making certain things which are grouped together logically and which can be seen as a logical independent part, and to manage that particular part, if I am doing a packaging of that, it means logically I am putting certain functionality in a package, and those functionality is being named with the help of certain package naming. So those all things can be seen as independent packages, and basically you can say that there is a container. Inside that container you are putting something, and that is nothing but a package. So you can make several packages in your project, and those different packages are available for the purpose of the functionality or working of that particular system when the system is being implemented. So to represent that particular aspect, package diagram is used. Now next comes the deployment diagram, and as I said that it is also one of the important diagram, and this deployment diagram is used to represent the architecture of the system. What actually the physical architecture of the system will look like. When I say the physical architecture or physical network architecture or physical software architecture which is going to be implemented, that means that what are the different physical components available in the system which are being used for the purpose of deployment of that particular software. It means there may be requirement of different database server, there may be requirement of different web servers, there may be requirement of different network connectivity, there may be requirement of different other tools or components like sensor. So different nodes you can say, as I give example of nodes during this discussion. So those different nodes if are used in your system, so how those different nodes are used in the system and what are their positioning and how they are related with each other, those all physical aspect of the system is shown with the help of deployment diagram. So just by seeing deployment diagram you can sometimes visualize the complexity of the system, that how many different physical or hardware component of the system is required, and obviously your whole software will be deployed there and it will be running on that particular hardware environment. So deployment diagram give a clear cut requirement of the physical infrastructure of the system. Now if we try to summarize the benefit of this particular structural modeling, then we can say that if we are having a structural diagram available to us, so it provides clear cut picture about the static architecture, static relationship of different component in the system, and it helps design and plan of the system properly, and it is easy to explain and share the system detail to the different parties, whether it is the customer or it is some kind of experts from whom you are looking for a review or some kind of advice, or finally the implementer or the coder or the software engineer. And then it saves time if you are having proper design of the system. At the same time you must have to keep on updating the things whenever some new modification in the requirement is coming, so that you are having a actual representation of the static view of the system just by updating different static or structural diagram in the system. Now what kind of challenges we may face when we are designing these things? So if we are having a very large or complex system and in that particular environment we are trying to visualize these things, so many a time gap exists between the actual requirement and the information gathered by the analyst. So those all aspects are very important to understand and to see. If the complex system is there, then different diagram you have to study very carefully, and whenever there is a certain change in the need or some kind of modification in the requirement or functionality, then you have to change your diagram accordingly. And maintaining consistency with the available design and the final implementation of the code is obviously a very big challenge, that how actually the 100% mapping from the design to coding is happening. And then expressing dynamic behavior, because it is a static diagram, so for that purpose we use behavioral diagram, not these static diagrams. So that is challenge, but that challenge is addressed by some other kind of diagram which we design when we are doing the UML design of the system. And balancing the simplicity of whole representation of the system, at the same time the completeness of the system, these all aspects we have to take care, then we can address the challenges. Now finally the benefits or the best practices which we can follow for the purpose of getting better benefit. Keep it simple as possible. It means each and every thread where you have to take care carefully, then only you can keep it simple. Use consistent naming convention so that a proper consistent diagrams are available and there is no confusion. Organize elements logically. use proper notations for the different diagram, and keep the diagram updated. So these are the few basic practices which we should follow when we are making the structural diagram. So with this, I conclude this session here. In this session, I discussed about the structural diagram and what are different structural diagram, what are different elements of the structural diagram. And for more detail, you can refer the study material of MCS 219 Object Oriented Analysis and Design. And best way is that you take some example and try to make certain diagram, and whenever you are having some difficulty, you can contact to us, and we will be trying to reach to you with some kind of support and help. So with this, thank you very much.